Hello. In this lesson, I want you to summarize data in two-way frequency tables and two-way relative frequency tables. Some vocabulary you're going to come across are two-way frequency tables, relative frequency, two-way relative frequency table, marginal frequency, joint frequency, conditional relative frequency, and association. So you've got a lot of vocabulary going on in this lesson. This lesson is really about categorical data versus numerical data like we've done the rest of the chapter. When you have categorical data, we can't really do too much other than look at it. And so one way we can do it is by making a two-way table. A two-way table shows you comparing two categorical data. Like in this example I gave you, we are comparing animals with the type of care they get when they go to the vet. So if we take a look at a two-way table, we just pretty much look at the question and answer what comes up. And sometimes it's more reading than it is anything else. So in example 1, it says, how many pets were sick this week? So if we look at the sick column, there are 13. So there are 13 animals that were sick. How many pets other than cats or dogs visited the office this week? So that would be the other category. And there were 19 total animals that visited the office this week. How many cats had a regular checkup? Well, that's just the cell here, then, isn't it? So the cell, there are 27 cats that had a regular checkup. And example 4 says, if the veterinarian takes appointments or takes approximately the same amount of time to examine a sick animal as a regular checkup, regular checkup, how should she plan to schedule her time? Well, to schedule her time, we're going to look at the total. So if we take a look at the total, she has 13 sick animals and 81 checkups. Well, that gives us a total of 94, doesn't it? We can see that from the chart. See, your total for both columns is 94. Well, then, let's figure out what percent of that is. So if we're doing sick animals, that's going to be 13 out of 94. Let's use a calculator to figure that out because I can't do that in my head. I want to use the scientific here. It's just, we don't need all that power. So we're going to take 13 divided by 94. And she should spend about 14% of her day with sick animals. And then for checkups, so 81 out of 94, well, take 100 minus 14, really, is what we're going to do. So we're going to say 86% of the day is going to be spent with checkups.